quadrilateral. You can show the proving of a cyclic quadrilateral in 3 ways. This should also be on your wall's matrix. This must be on your wall. The first thing is you can show that the opposite angles give you 180, or you can show that the exterior angle is equal to the opposite interior angle, or you can prove bunny ears equal. Those are the 3 ways that you can prove that a quadrilateral is cyclic. Some students say, but ma'am, it can't be a cyclic quadrilateral because there isn't a circle around it. Remember, you have to show that there is a circle around it. There won't be a circle around it because it's not a cyclic quadrilateral, yet it is a normal quadrilateral. So you must either show one of the 3 properties. Do you understand? And then it becomes a cyclic quad. So there were different things that you can do, but what I saw immediately, I saw that PQRS is a cyclic quadrilateral, right? So the opposite angles give me 180. So what is x plus x equal to? This angle is already 2x. Can you see? So what's the size of S? If that is 2x and the opposite angles give you 180, what is the size of S? 180 minus 2x. You are absolutely right. So in 3.3 I said S is equal to 180 minus 2x, and I used opposite angles of a cyclic quad. Good, everyone? Opposite angles of a cyclic quad. Right, I just want to repeat 3.2. Somebody is just saying, man, please, with hands going like this, please, can you just show me 3.2 again? The student who's asking that, can I show you? Remember, P1 was 90 minus x. So I said that angle R is also 90 degrees minus x because this is an isosceles triangle. Do you understand that? So this is 90 minus x. And that is 90 minus x. And this angle they gave me to be x. So all I did was I used the interior angles of a triangle, which is 180 minus 90 minus x, minus this 90 minus x, minus this x. Then I got that Q2 after I subtracted everything. I got that Q2 is x. So if this is x and this is x, it means that TQ bisected PQR. I hope that that helps you a little bit. There were 2 students who said they battled with that, so I hope that that helped you a bit. We are trying to prove back to our sum, STOR is a cyclic quad. Guys, are you okay with me saying this is 180 minus 2x? Because the opposite angles give me 180. And now, oh my word, do you know what I saw immediately? This angle here is then also 180 minus 2x. Remember in our previous sum there by 3.1, this angle is then 180 minus 2x, and this angle is 180 minus 2x, but this is the exterior angle of this quadrilateral. Can you see? This is the exterior angle of the cyclic quadrilateral. And there I immediately said that O1 is 180 minus 2x. I've proven it already. They are equal to each other because they're the same. Thus STOR is a cyclic quad. Reason, exterior angle of quad equal to opposite interior angle. I hope that you understood 3.3 completely. I hope. And even if you're battling a little bit still with 3.2, don't worry, guys. I hope that you've written down the solutions and that you can definitely go and try and solve it at home. Now, I've got about, let me just see, 5 minutes left. Henny just told me 5. I think that I can do, what do you think, 2 sums? I think so. Can we see? Or even if it's just 1. Right, in the diagram, and now we don't have to go to any theorems again because we know them now. Two circles intersect at A and C. Guys, what do you see BA is? BA is a tangent. Oh, when I see tangent, I look for a radius. And if I don't see a radius, I look for a chord. And then they just give me that these are straight lines. And then it says this is the center of the circle. Let B be X. First question. Prove that D is 180 minus 2x. That is not a difficult question, matrix. I'm going to turn my sketch. What is the size of O1? What is the size of O1? Look at the sketch for me and tell me what you think the size of O1 is. O1 is equal to 2x. Why? It's the center angle, and that is the circumference angle. So I am going to say O1 is equal to 2x. Are you happy with that? Center angle equal 2 times circumference angle. And they say that I have to prove that D is 180 minus 2x. Do you know? Look what I do all the time. I turn my sketch around all the time. Matrix, what do you see? Do you see a cyclic quadrilateral A, O, O, C, C, D, A, D. This is a cyclic quad. Can you see it? Because it touches, I'm talking about the big circle matrix. O, C, D, A all touches the circumference. So if this is a cyclic quad, what's the size of D? You know these two must give you 180. So angle D will be 180 minus 2x. And that is what I did. It's 180 minus 2x. Opposite angles of a cyclic quad. There we did the first one. And I'm going to end off with prove that AD is equal to BD. AD needs to be equal to BD. So you want to show that this angle here is X. Then BD will be equal to AD. What do you think you're going to do? The people who sent that message through to me, ma'am, that 3.2, it's exactly the same sum. Can you see you have this angle and that angle? You're basically going to say that angle A is 180 minus, what's the size of this? 180 minus 2x minus x. Look everyone, this is 180. Take your minus in. Take your minus in. Minus x. What do you see? What is 2x minus 1x? It's x. You have just proven that A is x. Oh my goodness. Your base angles are equal. So BD must be equal to AD. So you're going to say thus AD is equal to BD. And your reason here is equal sides or sides opposite equal angles. Sides opposite equal angles. Grade 12, the last question there, I think we can do it quickly because it's so easy. They just said that you must prove that TC is parallel to AB. Parallel, you must just prove either corresponding angles equal or your alternate angles equal. I saw a corresponding angle immediately. I said this angle is X. Why? It's my exterior angle of my cyclic quadrilateral. So I said CTD is equal to X. It is the exterior angle of my cyclic quad. And then I saw, but that is X. And this is X. And they form an F. What is a F? A F is corresponding angles. So I said this angle CTD is equal to angle A, which is both X. That means TC must be parallel to AB. Corresponding angles are equal. If your corresponding angles or your alternate angles are equal, your lines automatically becomes parallel. Grade 12, what a mouthful. And we have just got time until this sum. There was one more sum one more sum that I wanted to do, because there in question 6 it should say give angles equal to x, not in terms of x, but I think you can try that by yourself. I really want to say thank you to every student who sent all these WhatsApp messages and people who ask questions. I'm so proud that you're taking the time to actually sit and go through lessons with us. Thank you very much to all the schools who tuned in this afternoon. I hope that you learned something. Go this afternoon, put your theorems wherever you can see them, and let it become part of you. Grade 12, well done for tuning in, and good luck with whatever you still have to do today. Goodbye.